Good day, everyone. In this experiment, we will discuss the tensile strength of steel. This laboratory activity is important in civil engineering because steel is widely used in reinforced concrete structures, bridges, buildings, and other structural components that are subjected to tension and heavy loads. Tensile strength refers to the ability of steel to resist forces that attempt to pull it apart. Determining this property helps engineers evaluate the strength, durability, and reliability of steel materials used in construction. In this experiment, a universal testing machine, or UTM, is used to apply axial tension to steel specimens until failure occurs. Through this test, important properties such as tensile stress, strain, elongation, and deformation behavior of steel can be analyzed. This experiment aims to determine the tensile stress of steel according to its size and grade. At the end of the activity, the students should be able to determine the tensile strength of steel using proper laboratory procedures, understand the importance of tensile strength in civil engineering applications, apply testing techniques and engineering skills in evaluating steel behavior under tension. The materials and equipment used in this experiment include coarse, graded steel samples, cut-off machine, universal testing machine, or UTM, measuring tape or ruler. First, prepare the 12 mm diameter steel specimen to be tested. Next, with the assistance of the laboratory technician, set the universal testing machine to tension mode. After that, place the steel specimen securely inside the machine and begin the tensile testing procedure. As the machine applies tension, observe the behavior of the steel until fracture occurs. Once the steel breaks, record the load and deformation results obtained from the machine. Finally, repeat the same procedure for all remaining steel samples. Tensile strength testing is essential in evaluating how steel behaves under pulling forces. Since steel is commonly used as reinforcement and structural material, understanding its mechanical properties is important in ensuring the safety and stability of structures. During the experiment, the universal testing machine applied continuous axial tension to the steel specimen until failure occurred. The test allowed the determination of tensile stress, strain, elongation, and deformation characteristics of the material. The behavior of steel under tension demonstrates its ability to withstand external loads before reaching its breaking point. The measured stress and strain values also help engineers assess whether the material satisfies design standards and construction requirements. This experiment highlights the importance of proper material testing in predicting the actual performance of steel in real engineering applications. The experiment successfully determined the tensile strength and deformation characteristics of the 12 mm steel specimen. Based on the gathered data, the average applied load was approximately 50.225 kilonewtons, producing an actual tensile stress of 450 newtons per square millimeter. Compared to the theoretical value of 444.08 newtons per square millimeter, the percentage difference was only 1.332%, indicating high accuracy in the testing process. The computed strain value of 0.00015 showed that the steel exhibited elastic behavior under the applied load. Overall, the results confirmed the reliability, strength, and expected performance of steel under tensile stress, making it suitable for civil engineering applications.